All right, welcome everyone to our next webinar in our series on WSUD guidelines and maintenance. This is our second last webinar. We have the one today and then one next week, and then it's the CRC conference. So we're coming to an end with our webinars. Today we're very lucky to have Belinda Hatt presenting on the adoption guidelines for stormwater biofiltration systems, cities as water supply catchment, sustainable technologies, and Marie Powell, who's going to be presenting on the New South Wales guidelines for maintenance of stormwater treatment measures, highlighting biofiltration in wetlands. Because we all know that WSUD is great, but if it's not maintained, then it's probably crap. So, and then at the end, I'll be doing a bit more of I'll give a brief for what the next webinar is. Just as usual, we'll mute everyone except for the speakers, and the chat function is usually quite active in these webinars. So if you have any questions or any comments, just put them in the chat function and we'll try and get to them. I'm also recording this webinar so that we can post it on the CRC website afterwards so people can watch it who weren't able to attend. So if you don't want your video in the recording, then just make sure you turn your video off. And with that, I'm done, and I will hand over to Belinda.
All right, sorry, I've just unmuted myself. You can hear me okay?
Yes.
Yeah. All right, let me share my screen. Okay, so can you see that? Yep, all good? Okay, great. All right, thanks Beth for the intro. I'm Belinda Hatt. I'm from Melbourne Water. I sit in the applied research team at Melbourne Water. But before I worked for Melbourne Water, I was an academic at Monash Uni, and I was actively involved with the CRC for water sensitive cities when it was really in its, the first part of the program, when we were really heavily engaged in research, and I was involved with a lot of the research that underpins the biofilter adoption guidelines, which I'll talk to you about today. Beth, do I need to do a bit of an overview about what a biofilter is, or are we just a really quick one? Yep. Oh. Okay.
Sorry, yeah, just a really quick one. I couldn't find my mute button, and all of a sudden you see some Teams now, and I'm like, where is it? It's in a different place.
You can never find it when you need it the most. All right, so a stormwater biofilter on the surface looks just like any other rain garden, any other garden that you'll see in the street or in a house. But underneath the surface of the rain garden, there's a number of layers of really sort of carefully selected sands and gravels that perform both the function of supporting those plants that you see on the surface, but also treating stormwater before that's either captured for reuse or discharged to the drainage system or a waterway. And so what I'm going to talk to you about today is what's in these guidelines, and a bit more about what each of the components of a biofilter is, or a rain garden, depending on what you like to call it, doesn't matter. So these biofilter adoption guidelines were the first biofilter adoption guidelines that we published out of Monash Uni was back in 2009, and these are known as the FORB guidelines. The guidelines that I'm going to talk to you about today that we published based on the CRC research were published in 2015, and that was based on a whole lot of research that was done since those first guidelines were published. And so there was research that was funded directly by the CRC for water sensitive cities. So as Beth mentioned before, it was project C1.1, sustainable technologies. There was also a whole lot of complementary research that we undertook that examined the role of plants and other design features in biofilters. The research was both lab testing and field monitoring, and the field monitoring we did in Australia, Singapore and Israel. And the guidelines are also informed by a number of associated CRC projects that looked at governance and institutional arrangements and economic modelling and analysis. So that's the research that underpins the guidelines. And the process that we used to actually develop the guidelines was quite a collaborative process. So we'd done research and we wanted to write the guidelines. And we knew that as researchers, we had a really detailed knowledge of the scientific processes that take place in a biofilter, but not necessarily all of the ins and outs, the practicalities of implementing and operating biofilters. So the development of these guidelines was led by an industry advisory panel, and this included a range of different, well, we had representation from every state in Australia that was involved with the CRC, and a range of different sectors of so we had consultants and we had people from local government, people from state government, to really get a broad perspective on the practicalities of building and operating biofilters. And we thought this was really important because we knew that these guidelines needed to be relevant to stakeholders, and not just the engineers and scientists, but also those who are planning for biofiltration, and those who are really sort of looking at the aesthetics of biofilters, so landscape architects, as an example. The guidelines are arranged in a number of chapters, and if you've had a look at these guidelines, you'll know that they're big, they're long. They're not intended to be read from cover to cover. Think of them more as a reference manual where you're dropping in and out depending on what it is you want to know about biofilters. And so the introduction, I guess everyone should read, but then the other chapters depends on what it is that you want to know. Perhaps you're planning for biofiltration and you're interested in building a business case. Or if you're at sort of the more technical end, then the later chapters are probably of more interest to you. One of the new things that we did with these guidelines was to write a summary report, recognising that the full report is a very big and unwieldy report. So we wrote a summary report, and this provides an overview of all of the key design, construction and maintenance considerations. And this contains all the information that you really should need in order to be able to build a design and implement a biofilter. The summary report also provides navigation to key sections of the main report if you want to know more about particular aspects of biofiltration. So in the main part of the report, the business case for biofiltration, this is really about thinking at the early stages of building a biofilter, thinking about, well, why it is that you might choose a biofilter over some other stormwater treatment measure, and what you can expect, how to justify and endorse their adoption, and also to think about the economic costs and benefits. And so that's where we really drew on some of the other research to come out of the CRC. We've created a lot of illustrations and summaries to really kind of try to communicate some quite complicated information in a really succinct and clear way. So lots of information on how biofilters work, what components there are in biofilters and why they're important, to really sort of help people think about, well, where is it that you really need to stick with the guidelines, and where have you got some room to move? Illustrations around the design process, which I'll show you soon, construction checks, maintenance issues, and also what you can expect from a biofilter in terms of its treatment performance and flow management. So some of the essential components of biofilters. This is a diagram that's showing those essential components. Look, I'm not going to talk in great detail about each of these. It's all in the guidelines. But basically, what you need in a biofilter is a way for stormwater to get in. You need some plants and some filter media or some sand or other growing medium to support those plants. Both those are really critical components for enabling the treatment processes to occur. And you need a way for treated water to get out of a biofilter. Two other things that you also need are some pre-treatment, particularly if you're in a catchment where you're expecting heavy loads of sediment, because like all filters, biofilters can be prone to clogging if they're not carefully managed. And you also need a way to protect biofilters from high flows. And so that's what you see. And now I don't know if you can see my mouse pointer, but that's what this overflow is. And that overflow may be within the biofilter itself, or it may be upstream of the biofilter that preventing high flows from entering the biofilter in the first place. So what you can see here are a number of different layers of filter media. So this topmost layer is sort of a sand-based layer that supports plants and provides where the primary treatment is occurring. And then deeper down, we have got some transition layers and going into a drainage layer where treated water is collected. Now, one thing you might see here that I want to point out here is that the way that water exits the biofilter in this case, we haven't got a collection pipe for capturing that water and conveying it on post-treatment. The way that water is exiting the biofilter here is it's soaking into the surrounding soil. Additional components that you might want to consider for your biofilter, depending on what the purposes of your biofilter are, include a collection pipe. You might want to create an internal water storage, also known as a submerged zone, and that can really be helpful for improving treatment processes, but also providing a source of water for plants in between rainfall events. And so you can create that internal water storage or submerged zone by raising the outlet of the biofilter. You might also want to line the biofilter. Depending on what's around your biofilter, you might have some assets like a road or building foundations that you really don't want to be getting wet. And so you might want to line part or all of that biofilter. And so in the guidelines, you'll see there's a summary table that describes each of these components and what their function is, and also provides a section guide to help you navigate to the main section of the report if you need to know more about, if you want to know more about those particular components. I think one thing that we found that we developed here was in this volume of the guidelines is a flow chart to help you navigate through the different decisions that you need to make along through the design process. And so these are broken down into 4 main sections. So thinking about your objectives, what is it that you want your biofilter to achieve? Characterizing your site, understanding soil types, what's around your site, including the vegetation, what the aesthetics of your surrounds, because that helps inform the design process. And stepping through, depending on each of those site conditions, linking to design parameters that you need to consider, and some tips on risks to long-term performance and how you might manage those, minimize those risks. In these guidelines, we've also provided a much greater list of plants that are suitable for biofilters. So if you've seen the FORB guidelines from 2009, you will know that we had about 6 plants in there that we knew were really good for stormwater treatment. And that we knew at the time that was a pretty limited set of list of plants, but that was what we'd been able to research at that point in time. In between the first and second version of the guidelines, we were able to do a lot more research to expand that list to test a whole lot of different plants, so that we had a longer list of plants that we knew were good in biofilters, but also to understand what it was about those particular plants, what traits made them good for biofiltration. And so what we were able to do was to provide a much greater selection of plant species. So we've got some plants that we know are good, plants that we know perform poorly in terms of pollutant removal, and plants that are either sort of medium performers or those that perform differently under different conditions. So there's some plants that we know are good in wet conditions and poor in dry conditions, and vice versa. We also understand a lot more about plant traits. So if none of these plants are really sort of what you're looking for, perhaps they don't suit the look of the biofilter that you're after, there's also guidance in there on the sort of particular plant traits that you're looking for. So if you're after a particular look, you can go and find plants that suit that look and have those plant traits. The focus is very much on nitrogen removal, but we've also got a smaller list of plants that we know are good for other particular applications, like pathogen removal, if you're interested in harvesting that stormwater and reusing it afterwards. We've also spent a lot of time working with suppliers of filter media to improve the guidance around the filter media requirements for biofilters, because we knew there was a lot of confusion about what a suitable biofilter medium looked like. So again, we've got a summary table describing the different characteristics of filter media and why they're important to particular biofilter function. So thinking about providing a media that is able to drain at the rate that you want it to, but also support healthy plant growth. But there's real limits around that, in that you want to have lots of organic matter and nutrients to have really healthy plants. But if you have too much of those in a treatment system, then that can result in leaching of those very pollutants that you're trying to remove from stormwater. So some really clear and tight guidance around how much nitrogen or how much organic matter you can have in your filter media. There's also some other recommended filter properties. And I think one thing where there's been particular confusion in the industry in selecting appropriate filter media for biofilters has been around drainage rates versus particle size distribution. And we've put particle size distribution in the sort of recommended filter media properties rather than the be all and end all, because what we were finding was people were saying, okay, well, we've got a media that drains at the appropriate rate, meets all the other specifications, but it doesn't meet the particle size distribution, so it's not suitable. And I was actually, well, that's not actually the case. The particle size distribution is of lesser importance than the actual drainage rate and all of those other essential properties. Really, what the particle size distribution guidance gives you is a sort of a starting point to help you identify what could be a suitable medium. Also in the guidelines, there's some more specific guidance if you're interested in using biofilters as part of a stormwater harvesting system. So if you are designing for stormwater harvesting, then the pollutants that you're most interested in will be different to those if you're designing a biofilter for protecting waterways and bays. So we're much more interested in pathogens and toxicants, and so things to think about there to help improve maximise the removal of those pollutants. There's also a section in there on designing biofilters that look attractive, and so to increase the acceptance of biofilters by the community, because we know that there's some people that don't like the look of. Sorry, I'll step back. A lot of the plants that are, well, almost all of the plants that we recommend are native plants, and we've used those. Started with native plants because they're adapted to local wetting and drying conditions. But we also appreciate that not everyone likes the look of a native plant, and so there's tips in there on what to do if you want to design a biofilter that suits a particular look of your, and fits in with the surrounding area. And lots of practical guidance on maintenance and delay, things like how to delay clogging, and keep your biofilter running, operating to the best of to the full design intent for the full intended lifetime. At the end of the guidelines, there's a whole heap of appendices that provide break down some of this information and present it in different ways. So there's a whole lot of fact sheets and things on how biofilters work, on how to design them to meet particular objectives, how to so that they're suitable to particular site conditions. Sort of breaking down the bulk of the information into bite-sized pieces, depending on what it is you're interested in. There's also a publications list so that you can see all of the research and development that underpins these guidelines. And there's also some standalone guidelines as well, so particularly for the filter media, but also on designing biofilters that look good, and a range of maintenance field sheets and checking tools to help at the other end of the biofilters once you've designed them and got them in the ground, how to look after them. So I think that's sort of all I wanted to say today to give you an overview of the guidelines. And I guess to finish up with that, I just wanted to acknowledge the contributions of the co-authors and all of the researchers that did all the work that underpins these guidelines, and also the industry advisory panel that guided the development of the biofilters. It's certainly, I think if we'd written these guidelines on our own, it would have been a whole lot easier because we wouldn't have had to be trying to balance a range of viewpoints. But because the industry advisory panel was there working with us, I think we were able to develop guidelines that were much more relevant and much more useful. And so with that, I'll just say thanks for listening today, and hopefully looking forward to a good discussion at the end.
Awesome. Thanks, Belinda. One question has come through from Craig from Canary Bankstown. Maybe we can just answer that one quickly. It's if I had a rain garden with no filter media, but still accepted stormwater, what are the trade-offs?
So I guess if it was not specific filter media, like is that what the question is? That say just had.
I believe so. Yeah.
Yeah. So it's just had some sort of like sand or local soil.
I think so. If Craig, if you want to chime in.
Yeah.
Yeah, that's correct. Say just recognizing that sometimes filter media can be quite expensive, but if it were just standard sort of soil where the plants were growing.
Yeah. So just like say using a local soil, I guess in some cases it might be suitable, but local soils, soils don't drain at the same rate. So the trade-off is that you might be able to capture and treat some stormwater, but because the system would be draining at a much lower rate than intended, you'd have the system would be treating far less water, and so it'd be bypassing a lot more often. So if you thought about stormwater on an annual time step, what it would mean that instead of treating 90% of your stormwater over a whole year, which is what these systems are designed to treat, you'd be treating a much smaller proportion. Does that make sense, Craig?
Yeah, that does. Yeah, no, that's a helpful point. Thanks.
Actually, I might just weigh in there as well. G'day, Craig. We've recently designed a system which it's a biofiltration system that has no plants in it, specifically because the part of in the upstream catchment is a waste transfer facility, and the load of pollution coming in is phenomenal. It would smother everything in there and our plants would die. The key to keeping the thing operational is to do, number one, get the hydraulics right, and number two, make it simple and easy to maintain, and then it will get maintained. And then, yes, we don't have any plants in there, but it'll be functional and it'll work as best it can. It doesn't need to be beautiful because of where it is. So there are options to consider in that regards, mate. Sorry, over to you, Beth.
Awesome. No, that's great. Thanks, Mary. All right, I just see that there is one more question from Ben in there about filter media, since we're talking about filter media, so we might just go to that, and then we'll stop the questions and go to Murray's, and then we'll pick up the questions after Murray's presentation. So the one from Ben is, can you see that, Belinda? Around,
yes,
yeah, cool.
Yeah. So it's hard to give you like a really kind of definitive answer without seeing how far outside the conforming window, the conformance window these materials are. But I guess you've really got to think about in terms of pH, if it's outside that window, the pH guidance comes from the Australian standard for soil for gardens and so supporting health plants. So I guess if you're outside that window, then you might be able to find plants that will tolerate those pH conditions. Gradings, as I said, the particle size distribution is not essential, but really what you're looking for in a material, in a suitable material, is that you have all of the range. You have representation for all of the different gradings, and so you have all. So you don't have, and that's to make sure that the material is cohesive and that all of your fine material doesn't just fall right out of the media. You need to have representation across the whole range of sizes. That's to keep it together. But if it's doesn't strictly fall within the particle size distribution range that we've recommended, it doesn't mean it's not going to hold together. And organic content is really about leaching of pollutants. So we found that if you have, you need to have just the barest minimum of organic matter and nitrogen and phosphorus in that media, because if you have any more, then what happens is the plants are stripping nitrogen and phosphorus out of the stormwater, but all of those benefits are being completely undone because the filter media is then leaching nitrogen and phosphorus. to the stormwater, and so you get no net removal. Does that make sense?
Yeah, absolutely. Sorry, I didn't realize I was muted. Yeah, absolutely. Yeah.
All right, thanks, guys. All right, so let's turn over to Murray for his presentation. Can you share your screen, Murray? Thanks, Belinda.
You've got my screen.
Oh yeah, I was doing that, wasn't I? See, sorry, I'm not organized. I forgot. One moment, please.
People, there seems to be some sort of lag between my computer and the system. So I'd be talking on one page and you'd be all seeing a different one. So if Beth controls it at her end, we'll all have the same screen. While we're just waiting, I'll quickly add, Belinda, that's an amazing and excellent document. Way more thorough and comprehensive than anything else I've ever seen on bio, and a real credit to you know, the industry in Australia to actually have produced something that I reckon is of world quality. So congratulations to all the people involved.
Thanks very much.
And let me just add, obviously, having a focus in there, it is a stormwater device, and the primary function of stormwater is to get water away and not flood anyone. After you've not flooded anyone, then we can look at all the other things. So obviously, in due course, the hydraulics of these systems needs to be taken into account pretty comprehensively, and I noted that it was, and I was very happy to see that. I haven't had a chance to run through it in full detail, but very impressed with what I've seen. And the two things that stood out to me, first one was the requirement to have biofiltration systems that look attractive, because as you mentioned, the community and the residents, they just see what's on top of the ground, and they like to see color and plants and things that are you know, beautiful and attractive. They don't want spiky things and low ground cover that just doesn't look attractive. So I think there's going to be a bigger push for trying to find things that are a good compromise between aesthetics and functionality. And lastly, of course, having maintenance field sheets in there is a massive plus, and super happy to see those. And I'll be reviewing those to see how they conform with the ones that we have in this document that I'll be talking about right now. Okay, as you can see there, hello everyone. I had a quick look at who's attending. We seem to have a who's who of Australian stormwater. Welcome everyone. You would have had to have been living under a rock not to be aware that the Stormwater New South Wales has produced the New South Wales guidelines for the maintenance of stormwater treatment measures. In this, I'm just doing a quick overview to do a recap on some of the key features of that as they relate to biofiltration of wetlands predominantly. Let's go to the next slide, Beth. Right. That is the cover and the spine and the back cover. If people forget the name, because it's a very big long name, you can just call it the Yellow Book, and everyone will generically start knowing what you're talking about. Next. Okay, the main purpose of these guidelines is obviously to assist asset managers to actually do the planning for maintenance. If you don't plan for maintenance, it won't happen. Next thing is, if you don't have the money to make it happen, it won't happen. And obviously, if you are planning for it and you do have the money, you still typically, as a council who's owning most of these systems, you will have to probably tender for the cleaning contractors to do that. You'll obviously need specifications and everything else in that regard as well. And then you actually have to implement the guidelines and actually do the cleaning that's required. The guideline is very simply, from a maintenance perspective, about monitoring, about regular cleaning, and then about annual or comprehensive cleaning. And whilst those are pretty simple when it comes to things like GPTs, they're a little more complicated when it comes to custom designed and vegetated systems. Next. So obviously, the main asset managers for these stormwater things obviously include some of the water authorities for your larger bio and certainly large wetlands and things. Council has the majority of them. road authorities, Vic Roads, RMS, etc. They have a lot of spill control systems with dual functionality. They have GPTs, but they also have a lot of basins and things that end up becoming wetlands within their ownership. And of course, we have the private sector, of which a lot seem to want to do nothing and decommission them and rip them out as soon as they inherit them. There are some good people that know what they're doing, but they seem to be few and far between. Hopefully that will change as councils get better understanding of where these assets are going, what the maintenance requirements are, and putting covenants in place to ensure maintenance is done. Thank you, Beth. So the purpose of the guidelines is actually to assist asset managers, all the asset owners and the manager for maintenance of stormwater at all the councils. Obviously, if you are a road authority or a private asset person, these will equally apply, but these have been drafted specifically for the ease of use by councils. Obviously, they need to understand the maintenance methods applicable for each of the treatment technologies, the frequency with which that maintenance is actually designed to occur, the costs associated with that, and how the cleaning contractors actually think and how to get the best out of them. And then what tools and assistance they need for you to get the best out of your cleaning contractors. Next. But it's also written for the cleaning contractors. We want everyone on the same page. So there's details in there for each of the different treatment techniques where you specify exactly how to monitor a device. If you don't specify what to do, they'll turn up and do the quickest, least amount they can because that makes the most money, and they are commercial organizations. You need to specify exactly what needs to be done and how you want it reported. That's not only for monitoring, that's also for cleaning, reporting. If you don't tell them what you want, they'll give you the least they can. And obviously, if you want to validate the cleaning is done correctly, either someone would need to turn up and physically see that, or you would need appropriate photographs, etc. And in 99% of cases, they will suffice, providing you ask for the right photographs. If you just say photograph it when it's clean, then you may not be getting what you were expecting. Anyway, also understanding the costs associated with dewatering and how this can dramatically impact the cost of these cleaning all the different types of devices in the long term. Not particularly relevant for bio, but very, very relevant for wetlands. And obviously the plethora of wet device solutions where you have a lot of water in there, it can cost a lot to get rid of it. And there are lots of environmental things to understand when you're doing that. Obviously, risk and safety can't be understated. And understanding what gets reported and who's responsible for it and where it goes and what actions need to be taken as a result of that. If you just say, yes, we want reports on the cleaning, give them to me, and then you never reply back, you never check it, it's like people start going, oh, why are we reporting anyway? Nothing happens when we don't. So it's sort of a loop, a feedback loop that the industry will obviously progress in years to come. Thanks, Beth. So the main format for the guidelines, as Belinda had said, in her one starts off with an introduction, then you have relevant chapters. Same for this document. I've left off the introduction here, but the first major step is planning for maintenance. Then we have the asset handover process that is typically done quite poorly, although now it's being recognised that that's a fact and it's dramatically improving. So I'm pretty happy about that. Obviously, how to monitor all these systems, then the various cleaning, being regular cleaning and comprehensive or annual cleaning. And put simply, if you don't have things like bio and wetlands on your cleaning radar and your cleaning list, then they're probably going to slip under the radar and no one will be monitoring and no one will be cleaning. So even if they're only an annual inspection, they need to be on the list. Then obviously there's a section on waste management and disposal as people start to analyse further where the waste from these systems is actually going and our options for reuse and recycling. Water management and decanting is a massive area that we're going to be exploring and developing over the next decade, specifically in regards to minimising the cost of the maintenance that we're doing. Performance monitoring, in a lot of cases, if you have a biosystem and you put in the plants and the plants seem to be growing, well, you sort of put a tick in a box and move on. It's hard to know if they're actually stripping out the pollutants they were designed to. It's somewhat easier if you're looking at fixed solutions, media filters, GPTs, that sort of stuff. So performance monitoring in vegetated systems can be interesting, to say the least. But basically, if the water quality is good, it's not stinking, there's no algal blooms, and it's surrounded by a nice healthy ring of macrophytes, or the planting in your bio is nice and healthy, then you're probably on the right step. The final thing in here is auditing and asset rectification, because these things aren't set and forget. And a lot of devices have been installed over the past 20 or 30 years that don't really live up to today's expectations. So it's about also, having one eye looking forward and one eye looking back at all the infrastructure you've got. And it's important to be able to learn from the assets you've got in the ground about what works in your environment with your catchments, your rainfall, your cleaning budgets, etc. So doing an audit on what you've actually got in the ground, getting accurate information on it. And from that, you can obviously look at your cleaning specifications, the frequency of cleaning, etc. So it all starts by having good information on what you've got. Thanks, Beth. Planning for maintenance, I'll skip through this pretty quickly. Obviously, there is a cost per clean, and you clean it with a certain frequency, and I've got there plus, because there are plenty of other costs that aren't included in that clean times frequency. There's typically a cost to actually have your staff trained in what they need to do, especially if you're a council, getting them educated and, sitting in on Belinda and the CRC and looking in at, the way these things should be designed, should be operated, should be maintained. And obviously that training extends to the cleaning staff or the contractors that are actually doing the maintenance as well. Obviously you need data sheets on the assets that you have in the ground in order to understand how their status and if they're working or not. Cleaning specifications, so everyone is bidding on the same techniques and they all are cleaning in the correct manner. And understanding the scope of works if your cleaning is going to be more about a one-off consultant designed wetland or bio where it doesn't fall under a simple proprietary type nature, and you need to know where what's in and what's out with regards to dewatering, pulling out loads of vegetation, recycling of green waste, access to the site, pulling out media or pulling out sludge from a wetland. Scope of works is pretty comprehensive, or needs to be in some of these solutions. So you need to be planning for this in advance. Obviously understanding what plant equipment, tools and access you're going to need for your particular site, what you can and can't get in there. Training in relevant work health and safety. Obviously, if you're working in and around wetlands, risk of slipping and falling in is always present. I was cleaning a biofiltration a couple of weeks back and got bitten on my hand. And I was wearing gloves and doing everything right and I still got bitten. But obviously drowning, snakes, back injury when lifting things wrongly, etc. comes into play. But good maintenance starts with good asset information and then just throw lots and lots of money at it. Next. Okay. The asset handover process is very complicated. Sorry, it's not very complicated, but it seems to be that it's been a problem historically for all councils. In a lot of cases, councils have most of their assets with no information on them. You can get the majority that you need by doing an audit, but hopefully moving forward with the help of, Belinda's guidelines on bio and with a growing focus on maintenance, when these things are handed over, they can be handed over with the appropriate documentation. When these things do go in, obviously an inspection should be required, but by whom and when? I've specifically mentioned that because in a lot of cases, more so with GPTs and things, they're put in by contractors who don't seem to care. They just want to get out of there as fast as they can. As a result, you end up with things not meeting expectations, not installed correctly, And this is historically the very old original bio, the first sort of 5 years of bio. Contractors just cutting corners left, right and centre have left us with a legacy of bio that's in need of a bit of attention. Obviously, when you do get your assets in the ground, council needs to identify what information that they actually want. Obviously, works as executed drawings are an obvious requirement, data sheets and cleaning specifications. And for things like wetlands and bio, you may actually wish to have a site-specific operation and maintenance manual, hopefully not too onerous or complicated. Manuals that are, 50 to 100 pages and super complicated just don't get read. You want something that's a page, sort of 2 max, and beyond that, a number where they can go for help and assistance. But you do need to have a cleaning spec or an O&M manual for the majority of your devices. Obviously, in asset handover, one of the biggest problems that happens with most councils is assets get handed over to them with no consequent increase in the budget to maintain. There needs to be a process of every year, council says, well, we've just accepted, another 5 GPTs, another 15 bio. That's going to cost us, ka-ching, another $50,000 a year. And that needs to be put into budgets. Otherwise, things just get stretched way too thin and everything gets cleaned down to a budget instead of up to a standard. As I mentioned there in the capital letters, get it added to the cleaning list, because councils sometimes struggle to get accurate information on their proprietary type GPT solutions. These ones, especially when you start adding in swales and bio and things, sometimes they're just not on lists. It seems to be the green infrastructure is harder than the grey infrastructure. And as we've mentioned in the guidelines themselves, there's a good section on the maintenance and asset handover processes in relation to green assets in some stuff by Water by Design. Thanks, Beth. Okay, just quickly, everyone knows what primary treatment options are. These are going to have a huge impact on how your secondary bio and wetland treatment systems function. Obviously, a range of pit traps, gully pits, gross pollutant traps, wet and dry, trash racks, nets, booms, sediment forebays, all this sort of stuff. They offer a range of treatment performances at a range of different cleaning costs. Thanks, Beth. But when it comes to secondary treatment, or your more green solutions, if you like, some of these aren't particularly green, being permeable paving and oil and sediment separators. But obviously, you need to use the correct treatment technique depending on what's coming off your catchment and the loads you have to deal with. But certainly down the bottom of this list, infiltration basins, vegetated and grass swales, ponds and basins, bioretention and rain gardens and constructed wetlands, the ones with a very green component to them, they're more custom, they're more sexy, they're more interesting, but to date they sort of haven't really had the focus on maintenance that some of them will have deserved. Thanks, Ben. Right, just a quick recap. So for every single device, it's broken up into monitoring, then regular cleaning, comprehensive or annual cleaning. Thanks, Beth. With ponds and wetlands, quickly, this is your monitoring. Typically, inspect monthly in the same place. If you send 2 different people and they go to 2 different places in the wetland, they'll come back with 2 different results and they're now both irrelevant. You need to consistently monitor in exactly the same place. And hopefully people, there's been some thought as to where that is. If you monitor right at the front and you get a heavy sediment load, you could be cleaning too much. If you monitor right at the back and everything's dropping out in the first half of your wetland, then you could have the opposite effect. Obviously, it's important to inspect inlets and outlets. At the end of the day, these are a hydraulic system. They have to function for the storm water going through. If inlets are blocked or if outlets are blocked, they compromise functionality, not just the performance for your storm treatment. They can also impact flooding. A typical bugbear that I've seen done wrong many times is the use of macrophytes around an outlet to sort of hide it and shield it. especially if that outlet is near the bank. The problem with macrophytes is during a flood event, they all fold over and coat over the top, and then you've compromised the functionality, and now we've got overland flow happening because your outlets are blocked with macrophytes. Obviously a good idea to keep some room around it and keep your eye on the maintenance of that. Bathymetric surveys, ideally do them once a year, but they're bloody expensive to do. They're quite manual. You can probably extend that out to every 5 or 10 years if everything else in the wetland is looking good. Inspection of pre-treatments, as I mentioned. If it's part of a harvesting scheme, obviously gates and access, pumps, float controls, that sort of stuff do need to be regularly monitored. And apart from that, obviously vegetation and weeds. The community will see litter and weeds and think the wetland is horrible. I've had the same wetland described to me as a swampy cesspool full of mosquitoes and snakes, etc. And it's horrible. When can you fill it in? Another person saying it was beautiful. It had the something or other dragonfly was in there, and there were these beautiful butterflies, and it was a real beautiful ecosystem. So they say eye is in the beauty of the beholder, and there were a lot of things to take out of that. You'll never keep everyone happy, but the better you can keep on top of weeds and litter, the better for everyone. Okay, next. Regular cleaning for your wetlands is typically focused on the GPT upstream to remove hopefully 90 to 95% of the physical pollution load from getting in, and hopefully the fine stuff, the finer organics, neutrally buoyant stuff that does get in can be biologically consumed as part of the natural ecological processes. If you can't have a GPT, perhaps you're looking at a fallback position of a sediment forebay with or without a boom. You can obviously use macrophytes and things to help try and corral primary treatment, but you certainly don't want to have a whole bunch of pipes coming into the center of your wetland and everything just spread right out across. That just is the most expensive to look at maintaining. Obviously, the more you can segment your wetland underwater, the less impact you'll have when you're pumping down water volumes, less water you got to get rid of. And obviously, if you're then catching turtles and things and letting them go, you can let them go in the rest of the wetland. And when it all fills back up, they'll populate back to where they want to be. So there are far better designers in this world than me when it comes to wetlands. But from a hydraulics and from maintenance point of view, that's a key one that I would always like to see in there. And obviously each wetland or pond will need its own site-specific cleaning, access, ideally a low flow bypass while you're cleaning it, because you don't want to be pumping the water out while it's busy filling back up. Decanting, whether you can dry sludge and things that are pulled out on site, or whether you need to suck it into trucks and take it away. The more stuff you can do on site, the less water you take away, the cheaper and more effective cost effective it's going to be. And obviously you need to understand the biological impact with water volumes, depth, and vegetation that's actually in these things. Thanks, Beth. When it comes to comprehensive cleans, that'll be very specific to your device and is normally when you're talking about pumping down wetlands. If your wetland is typically above 50% full from its original design, it's really reached the point where that stuff you've caught is going to go anaerobic and cause problems. You don't have the residence time in there. You're not achieving certainly half of the original design intent, and that would look to trigger a cleaning. Obviously, if you've got weeds and algae, these things can either be addressed with poisons or manually removed, or mechanical means in some cases. So lots of different ways of addressing that. There's a couple of companies that specialize in that in the industry, but I'd advise councils to get specific advice from probably a couple of key consultants and probably a couple of key contractors in this field before they start writing specifications on what to do. Get some input from the experts as to how they would do it, and then take it from there. Obviously, when you're talking about wetlands, a couple of things that will trigger the need for cleaning include bird deaths and algal blooms, definitely. So if those start popping up, a comprehensive clean is probably on the cards. Thanks, Smith. Right, I've just said you need site-specific stuff for your wetland. That's fine, but just as a reiteration, pre-treatment in front of your wetlands is so much cheaper and easier to clean than cleaning your wetland. So if you do have effective pre-treatment, you are leaps and bounds ahead of when you don't. Thanks. Next. Typical dollar values, site-specific cleaning spec, you're probably looking at $1,000 to $3,000 to actually have one produced. Based on this, you can get a bill of quantities and specification for what you're looking to achieve. Being a biological solution, even though it was built potentially, you will potentially need an REF, etc. Those can be cheap, they can be expensive, depends on the size and what you've got living in there. Obviously, ducks and birds can bring high bacterial levels into some of your wetlands, and sometimes these just get massively overloaded, and you do need to look at culling them. I believe this needs a license and would be considered part of a comprehensive clean because they are part of the problem that's polluting your waterway. And carp are the other big one, of course. Couple of different ways of killing those, apart from getting out there with a piece of bread and a float and trying to pull them out one by one. That typically doesn't work too well. But yeah, fishing, draining, using electricity, etc. Carp can be an issue. Thanks, Beth. When you're looking at what water quality testing you would need to do in your wetlands, I'm a big one for not over testing and not spending lots and lots of money on testing unless you see a need for it periodically on an annual basis. So it's not a monthly thing, it's probably an annual thing. You would do a standard suite and you would do it for all of your different waterways. When you start getting elevated levels of something, obviously you can look more into those individual parameters. The funny thing is, if you go out and test DO and pH 1 week and then it rains the following week, everything's different. So I wouldn't be putting a lot of emphasis on it, but I would be trying to say, test your waterways after a week of no rain consistently each time you do it. So it tries to minimize the input of new fresh water, making your systems seem better than they are. If you do have poor pre-treatment or poor operational maintenance of your pre-treatment, you can have GPTs and pre-treatment systems actually go anaerobic and become part of the problem. So obviously keep an eye on those. And if you don't have the GPT and all the organics are going in and being caught in your wetland and then going anaerobic, you've got the same problem, but now it's twice or triple or 10 times the price to address it. So there we go. Thanks, Beth. I didn't realize there were so many slides on wetlands. Obviously, the dewatering of these things is incredibly complicated, and bypassing of water when you're doing it is incredibly complicated as well. We were actually involved in a wetland which had been neglected for about 20 years. It originally started as a spill control basin, the Blackmore wetland over in the West Council, and we sort of innovatively reused a lot of the vegetation and buried it under all the sediment we took out, because everything was just, there was so much sediment in there, and it would have cost an arm and a leg. It would have doubled the price if we'd added all the disposal into it. So we buried it, planted over the top, well, topsoiled it, then planted everything. And interestingly, we got macrophytes growing out of, they weren't initially in the wetland, they were growing in all the surrounds. It was actually quite interesting and a real success out there. But again, that was offline and much easier to deal with than Centennial Parklands at the moment, that are going to look at dewatering and cleaning one of their ponds for the first time in about 30 years. And it's got 2 meters of sludge in the bottom of it and 2,000 cubic meters of sludge to come out. So bypassing is a big issue. Where and how you dewater it, there's lots of issues and lots of risks with that, of course. And then when you pull it out, what do you do with all the water? And obviously, once you've pulled out the sludge, what do you do with that? How do you stack it, store it? How do you dry it? And then what do you do with it? Can you reuse it or can't you? So cleaning of wetlands, very expensive. My advice, make sure your pre-treatment works and you look after it. Try and minimize your cleaning of wetlands. just as a quick one, if everyone's having a look at this slide, look at that beautiful nuclear green water. That's not dye, that's just how we turned up and went, wow, what the hell's happening here? Next slide. It was nuclear green with some outrageous algae. The pre-treatment had been non-operational. There were 2 lines coming in. Both pre-treatment solutions had bypassed. Diversion meant there was no flow coming into the pond, so it had gone completely stagnant. The pond was too high, so it was, well, too shallow, I should say. There was sporadic vegetation, anaerobic breakdown, nutrient cycling. Anything and everything was going wrong with this poor wetland. There was no planned access and poor ability to actually get in and maintain it. Having said that, 2 years later, after the audit was done, rectification works were planned. The rectification works were all done. The GPTs were cleaned and fixed. They got the hydraulics right. They got an access in there. They did planting, and with new fresh water regularly topping it up, the treatment process all came back, and the wetland is now spot on. So you can bring these things back. None of them are a lost cause. Thanks, Beth. Righto. Bio is not nearly as long as wetlands, but obviously inspections of inlets and outlets. It's important to understand that if you don't tell people exactly what you want done, they'll turn up, they'll trim some of the vegetation, they'll pick out some of the litter, they may or may not take some of the sediment, and they'll call that done. In some cases that may be acceptable, in others certainly not. Depending on whether it's a little 1 metre by 1 metre rain garden, or it's, hundreds of square metres of bio. Typically hydraulic testing of these things can be in the order of about $4,000 a year on average. That would be for a couple of sampling points. Obviously, it could be a lot more expensive if you wanted to add a very big solution and you wanted to test it all. It could be cheaper if you've just got a single tree pit type thing that you do want to check. But at the end of the day, inorganic materials will build up in the media profile, and at some point it'll trigger the need to remove them. And hydraulic conductivity is typically that trigger, but it's expensive to actually get that in place. So my other advice would be, if any of these systems are ponding water for more than 24 hours, that would be the trigger for either we're doing hydraulic conductivity testing or we just go straight to cleaning. The other little thing is the subsurface collection systems, certainly ones where you've got a subsurface slotted drainage pipe, etc., and then it flows up and goes out. That pipe at the bottom can get filled up with silts and sediments and that sort of stuff. Much harder to jet than a straight pipe through. If you've got a bend and you've got an elevated water level, you want to keep a better eye on your collection systems and probably jet them manually, because you're not going to be able to put a CCTV camera down there because the pipes are full of water. Anyway, next. Some of these things may or may not need a site-specific cleaning spec. In the guidelines for the maintenance of stormwater treatment measures, there it is. Ta-da! Get yourself a copy. You may have multiple solutions that were designed on the same basis, and you don't need a separate one for all of them. You can use a generic one, and certainly the advice and guidance in the adoption of biofilter information out of the CRC, WSC, there's some great stuff in there. So you may not need whilst with all the GPTs and that sort of stuff, you need a site-specific cleaning spec for every single one. These, because a lot of them are similar, you can get away without it. Obviously, regular cleaning involves picking up litter, pruning vegetation, ensuring no erosion, no bypassing and removal of sediment. Regular cleaning is largely classified as surface level cleaning. Thanks, Beth. The more comprehensive clean is obviously looked at removing a layer of the media. Experiences told me years ago when I was with the EPA and they were looking at sand filter design for treating flow coming off car parks and roads, which is where a lot of your bio downstream of car parks and roads. You do get asphalt roads, which are made of bitumen and stone. The bitumen is a hydrocarbon. It breaks down the sun, and you get a constant, very low level sheen of hydrocarbons coming off every bitumen road. Not to mention, stuff off tires, etc., etc. So you can get a layer building up. And what typically happens is the majority of the inorganic sediment and that sort of stuff, and if you do get blockage, it's all in the top inch. So you can come in with a spade and scrape off the top inch of media or sediment, etc., and typically bring back 80 or 90% of the life to your bioretention. And you probably want to put another inch of new stuff back. But if that's not sufficient and you've had too much in the way of fines and clays come in, your system is not reaching its hydraulic conductivity objectives, then you may need to be in line for a rebuild or a reset, which typically means ripping everything out. It's very hard to use an excavator and not smash through all your PVC piping. Alternatively, you can use a suction cleaning system. Sorry, something buzzing around my head. And sucking out everything, but of course that's at an increased price. But as part of a comprehensive clean, I would definitely be looking at an inspection or a flushing of the subsoil drainage lines, and then a significant volume of new plantings are likely. Look, comprehensive cleans on bio might need to be done once a year if they're a small bio with a large catchment and they're dealing with high flows and high loads. If they're well sized, you could probably get away with maybe up to 10 years, but it does depend on multiple parameters. It's a bit of a suck it and see. And as part of your cleaning specification and a bit of experience in the first few years, you should be able to work out the appropriate cleaning frequency. Thanks. So, obviously, the O&M guidelines are available from Stormwater New South Wales. You can log on to the website and look at getting yourself teed up for a training course and getting a copy. At the moment, all the other states are looking at getting the guidelines updated for their own states. So it's very likely that within the next 12 months, South Australia, Victoria and Queensland will potentially have these guidelines updated for Stormwater Queensland, Stormwater Vic and Stormwater SA, and they'll come out relevant to the locals down there, and they'll be coming into use. There's lots of practical, great information. It's very practical. There's no design stuff in it. It's all about maintenance. There's one-page cleaning specs for all the proprietary type solutions, and that's a real advance in the industry that was never there before. The great thing for councils is you'll basically be able to say when your next cleaning tenders are coming out, clean in accordance with the guidelines. So if you don't have an individual one-page cleaning spec for all of your different devices, you'll be able to refer to this, and then that gets you at least halfway to 3/4 of the way there. So we're, as part of the stormwater industry, we're looking to make life easy for our key clients, of which councils are top of the tree, and obviously all the other asset owners that deal with these things. But if you could just say clean in accordance with the guidelines, that's going to get you out of trouble a fair whack at the time. We are running relevant training courses every month or two. So councils and cleaning contractors should get themselves along, get trained up in how to use these, and we'll be in for a bigger and brighter future. And I'll finish with the line down the bottom there. The good asset management requires a hell of a lot of maintenance. Thank you very much.
Thanks, Murray. That was great. Awesome. Okay, so we've had some questions come through.
Yes, I saw lots of questions pop up.
All right, let's go back to the top. Okay, so we are at, in planning permit drawings, should we get them to note that the rain garden system should be to engineer's details or similar so it is designed and constructed correctly? So I don't know if that's more for Belinda.
Yes, I think, yeah, because without the engineering drawings, you haven't got enough detail. You need those levels to be right. I've seen so many systems that have been built with the filter media. The surface of the filter media is higher than the the road that it's draining off, and so there's no way for water to get in. Or I've seen systems where the overflow pit is set at the same level as the filter media surface, and so stormwater runs in and just straight into the overflow pit. And even worse, the overflow pit is right at the inlet and level with the inlet and the filter media surface, so the water just doesn't even get into the biofilter. So I think it just goes straight into the overflow pit. So yes, you need those engineering drawings, because they've got the levels there and enough detail that they'll be built correctly.
Awesome.
Let me just add in something to that, Belinda. And I've seen this on more biosystems than less biosystems. So more than 50% of the time, the same problem is happening again and again and again. And that's where you've got a pipe coming out of a GPT, and then you've got the level of the biofiltration. It's either at the same level as the pipe coming in, or it's actually above the level of the pipe coming in. And they just sort of put some rocks to sort of minimize erosion and expect the flow to sort of jump up and pool and then spread out. What that actually does, though, is it puts a backwater on your GPTs and your pre-treatment, which lessens their effectiveness, sends them into bypass, and sends all the pollution into the bio. So what I would love to see is where a pipe comes out from your pre-treatment, a 100 ml drop, and then you've got your bio or whatever's happening there. You don't want the secondary treatment to impact the hydraulics of the primary treatment, but it's done so badly again and again at the industry at the moment.
Good design and construction is critical. And I think, Mary, you made a comment about the maintenance frequency being a little bit unpredictable. We did an audit at Melbourne Water. We did an audit of a number of our wetlands and rain gardens a couple of years ago, and we found that most of the problems with our systems could be linked back to design or construction, the design or construction phases, rather than inappropriate maintenance or no maintenance altogether. So it really is really critical. If you want to minimize the amount of maintenance that you need to do on your systems, you need to design them correctly and you need to build them correctly.
Agreed.
That sounds good. All right, next. So someone's asked if I can share a copy of the presentation slides. I can talk.
Happy to.
Happy with that, Marie?
I'll email them to you, Beth.
Thank you. I'll send them around to everyone who registered for this webinar, so you have them. What environmental permits are needed to clean a wetland?
As a Victorian, I can't answer that question.
Oh, it depends where you are. If you're, hello, Adrian, I see your name on the list, mate. If you're looking to clean a wetland in the heart of city of Sydney, then there would appear to be a whole lot of environmental impediments, because you need to deal with, is it a Step 14 wetland? Who owns the wetland? How are you getting access? What's the cleaning process? Are there REFs and other things involved? If you're a country council, there's probably a lot fewer impediments. You've got better access, more options for dewatering, etc. So I think it's largely falls back to council, unfortunately. And
if you contacted the council, then they would be able to tell you what you need.
Sorry?
If you contacted the council, they should be able to tell you what they need.
Exactly. I think every council's got their own requirements, so definitely contact council, ask them.
Cool. All right. Instead of, I don't know if I can say this word, bathymetric survey, could you use a water quality probe with the depth measured and levels of turbidity rising when the bottom is disturbed? This could then be done within council?
Well, bathymetric survey is measuring the depth from surface of water down to the base or the level of pollution that's in there. You can actually, typically, depending on what the pollution is, if it's silty and sludgy, you can typically push a staff through it down to what was probably the original base of the wetland or pond. If it's largely organic, you can again push down through it. But typically, if it's taken up a certain volume, use your bathymetric survey to measure the depth of free water above the pollution. If you actually have accurate Works as X drawings, that will tell you how full your system is. I've done it in a wetsuit, swimming across a wetland and dipping my staff in and yelling out to someone on the bank every 2 meters, this is how deep it is. I've done it on a kayak, on a stand-up paddleboard, etc. So it's, and I've done it in a boat. There you go. So
Well, an easier way to do it might be one that Emma suggested, which is using a drone. So that might be a little bit easier.
I'm not familiar with how they would do that, but I'm all ears.
I don't know. Emma has just said drone option for bathymetric surveys may reduce costs and increase efficiencies in monitoring costs. I'm not really sure.
I reckon a drone would potentially be 1/10 of the price. And if that works, I'm all ears.
Rather than taking a dive.
Yeah.
All right, Angus. Can anyone recommend a landscaper designer who are good at wetlands / ponds in the Sydney region? David Knights has been suggested. I don't know if there's anyone else. I don't know if this is really the right form for that.
Yeah, look, there's a couple of there's probably about half a dozen main consultancies that are great at design of the green solutions, if you like. It's probably not the right forum to go advertising different companies, but if you ask around, I'm sure there'll be people that will point. David Knights is definitely in the mix, but there are others as well.
I guess I would suggest contacting Marie offline. So I've put the link for the report in this already, and I'll include it in the email that I send around after the webinar as well, just so everyone has it. How to protect gross pollutant ends up through the inlet in rain garden. Any methodology or technical guidance to prevent? How to protect gross pollutant?
You would either have to have some form of pit trap or trash rack or something to catch them in front of the rain garden.
Mhm.
In a lot of cases, that's problematic and hydraulically it may not work. You may have to just acknowledge that there will be an inlet zone, which, Belinda, keen on your thoughts. Do you actually sort of segment it and almost design it with a sacrificial, 1 square meter, is going to regularly get cigarette butts and sediments and other things? Or do you just sort of plant a ring and know that you've just got to clean that front area a little more frequently? But look, in some cases, there's very little litter and it's mostly leaves and things, and people aren't offended by that. In other cases where you've got high density stuff, City of Sydney and City of Melbourne type stuff coming in, there's not as many leaves, but there's a hell of a lot of litter. And people don't like looking at a garden full of litter.
Yeah.
So
yeah, I think it comes back to you need to know your site and your catchment. And so if you're in a commercial area where there's higher volumes of litter, or if you're in a catchment where there's a lot of deciduous trees, and so on a seasonal basis your system's going to end up with a lot of leaf litter in it, then you need to know it and think about it accordingly. And there are some ways to design it out, but it might also come back to that planning for maintenance. And I guess the thing to remember is, people don't like to see litter in rain gardens, but remember that that's kind of part of the function of stormwater treatment systems. If the litter is being trapped in those rain gardens, it means it's not in your creeks, and that's a good thing. And so perhaps it's either it's know your catchment and plan and respond accordingly, whether you design it out or you accept that you're going to have higher maintenance demands removing that litter from your systems.
One of the other things that hasn't been hugely taken up in the past, but I think will be more on the radar for the future in tight sites, especially your high density cities, would be to run flow through some form of primary treatment, typically gross pollutant trap, and then having a little pump well beside it, and then taking the screened water into the pump well and pumping that up into an above ground vegetated treatment system. So you're not limited by space on the ground in between a gutter and the parking lane and trying to squeeze things into a tight spot. It opens up where you can put it, and you've got a lot more options of how to use that, and you can control the hydraulics. So I think that'll become more prevalent in the future when we run out of nice easy spots. The hard spots, that'll be an option for further consideration.
Do you have nice easy spots to put your rain gardens in Sydney?
Hell no.
In Melbourne. I guess the other thing you could do, if you did have that sacrificial area at the start where you deliberately trapping litter in a way that's easy to remove, you could, as Murray said, you could have something like a bubble up pit so that water is then coming up through a surcharge pit into your system. And I guess that also helps with erosion, managing erosion as well, because it takes some of the energy out of the flow.
Awesome. All right. Is the Stormwater New South Wales guidelines being updated soon?
Yes, yes. It's partly done now. I'm behind the 8 ball. It should have been done by the end of February. When's that?
Yesterday.
Yes. It should all be updated by the end of March.
Awesome. Okay, cool. Another question is there appetite in the industry to create a national standard to drive consistency in maintenance, including data collection, the latter of which would be important for evaluating effectiveness of different measures and their costs?
Well, certainly these guidelines will effectively become a national guideline once they're adopted through all certainly the eastern states. I would be gobsmacked if Perth didn't look at bringing them online in due course as well. But oh, and Tassie, sorry, forget about you guys down there. They will largely follow Victoria in what's happening there. So I expect them to take it up as well. It will be a default standard, if you like. But when it comes to the monitoring of the performance of all of these devices, there's no one given document or standard that I'm aware of at the moment. So maybe that's something that for the Stormwater Industry Association, maybe Stormwater National, to put on their agenda as to something beneficial to look at over the next decade.
Yeah, I think
isn't it? We're all grappling with data management, and as our data grows and grows and grows, I think every organisation is grappling with how do we manage this, and how do we deal with this?
Awesome. Okay. And then, so Adrian has made a comment. So at City of Sydney, we developed what we call a bypass inlet pit, which doubles as a primary treatment to our rain gardens and traps litter.
That's all. More pre-treatment, the better.
Yeah.
Awesome. That's all the questions. Unless anyone has any other questions, you can also unmute yourself and talk now. I will allow you to do that.
Hi, this is Shala here from Hobson's Bay City Council. I wasn't sure if this was answered. I just took a quick break there and came back. So has the future rainfall patterns due to climate change been factored in these design and maintenance? Because I heard Murray saying about the volume falling below 50%, and then you need to dewater and things, and then we'll have long periods of dry and very intense rainfalls in future. So is that something that has been factored in?
I can answer that. No, full stop.
Yeah, not explicitly in the design guidelines either, but I am aware of other research that is being done that's looking at the changes in expected runoff as a result of climate change. And in our urban areas, the reductions in rainfall are nowhere near the reductions in predicted reductions in runoff are nowhere near like what we'd see in an undeveloped catchment, because we've got such hard surfaces and those surfaces and the drainage systems are so good at collecting runoff that we won't see the reductions in runoff that in urban areas that you'd see in, say, our water supply catchments.
The other element, of course, is sea level rise, and there's a lot of places where low-lying drainage systems will go underwater and will need to be upgraded in due course, etc. But the maintenance guidelines don't take any of that into account. That would be a design parameter, and obviously good design guidelines, including blenders there, will be key to achieving that. But from a maintenance perspective, no, it's just how to maintain the assets that you've got, and designing is different. Thanks.
Yeah. And I think it's coming. It's certainly on Melbourne Water's radar, and I know it's on DELP's radar as well, which for non-Victorians, that's our Department of Environment, Land, Water and Planning, about how to design these systems and taking into account different climate change scenarios. It's coming, but it's still some way off because it's a non-trivial process.
Thank you very much.
Right, anyone else? All right, well, we have gone over time, so I might end it there. Thank you very much to Belinda and Murray. Both very good presentations, and I think probably the best Q&A session we've had so far, so that's awesome. Thank you very much to everyone who participated as well.
I'll see you around the traps.
Thank you.